Hi everyone, this is my sister Taylor. She's going to help us demonstrate how we can teach our students how to find the area of shapes during our geometry units. So Taylor, the first thing I'm going to ask you to do is how can you make sure the end of your strip is perpendicular to the length of your strip? So the first thing Taylor did was she folded this strip in half. So now there's a crease here and she's showing that the length is perpendicular to that crease. Thank you so much, Taylor. All right, how can you get a fold line that is parallel to the edges of your strips?
Fold it the other way.
So Taylor took the rectangle and she folded it down the middle to show that it's parallel. She made a line that's parallel to the edges. All right, so now that we've worked a little bit with parallel and perpendicular, we're going to move on to rectangles and parallelograms. So the first thing that we're going to do is you're going to start with this rectangle here, and I'm going to ask you to consider how many different ways can you make one cut on that rectangle and turn it into a non-rectangular parallelogram. So how can you cut it to make it a parallelogram in just one cut? And you may use the scissors to do this. You know what to do.
It's not going to be even.
That's okay. Just think, just one cut. Okay, so Taylor cut the rectangle with a diagonal line. So now show us, or show me, how you can make a parallelogram with those two shapes.
Uh-oh.
It's okay. Keep working with it. There's a way to do it. Yep.
Oh, okay.
It's a little uneven, but that is good. So Taylor, with a little bit of guidance, found that when you flip them so that the trapezoids are opposite, you can create a parallelogram. So now we have a parallelogram. Now I want you to think. I'm going to give you this circle, and while I'm creating this, I want you to think about how you could cut this circle. I want you to cut a diagonal line across it with the scissors. You gotta hold it in the middle so that it stays. And then go ahead and cut it diagonally. Taylor's left-handed, only one in the family.
Okay.
Just as much of a diagonal line as you can, I guess. This will be interesting. Maybe just cut it down the middle and just see what happens.
Can you hold it?
Don't cut my fingers.
Uh-oh.
Alright, so Taylor has cut that circle for us, and they've created parallelograms. That activity is a little hard. I don't know if I'd recommend using that one. But it is a good way for your students to see the relationship of cutting the edges without starting with a direct shape that they know. So we're going to go back to the parallelogram that we have on the table. So how many places could you cut a parallelogram to form a rectangle?
Do I do it?
No, you don't have to do it for this one because you've already cut it. Because you have a parallelogram. So how many, or if you could cut it, how would you cut it to make a rectangle?
I'd cut that out and then flip them.
So Taylor said she would, if this were still one shape, that she would cut from the vertex up here down so that she makes a triangle over here, and then she'd cut from this vertex up to here, and then she'd flip the triangles to make it a rectangle. Are there any other ways that you could think of to make a rectangle from that?
By cutting it?
Mm-hmm.
No.
Okay, that's okay. So the one other thing that you could do is you could just cut off this and then just slide
Oh,
that
over
piece
here.
over. Mm-hmm. Or you could cut it in half like it's already cut and you can turn them and that makes a rectangle. So do you think there are a finite number of ways to cut parallelograms to turn into rectangles or an infinite amount of ways?
Infinite.
Infinite. But what are the conditions then? If there are an infinite number of ways to cut it, if starting from here, you would either have to cut them this way or this way, correct?
Yeah.
Yeah. So then, what are the conditions for it being infinite? For it being an infinite number of ways to cut it?
They have to be straight lines.
They do have to be straight lines. And then what were we working on earlier?
Oh, folded?
No, what's the words on it?
Oh, perpendicular and parallel.
Yeah, so they either have to be perpendicular or parallel to the lines that are already created. So now I want you to think about a formula that you could create since you already know that the area of a rectangle is
The base times height.
base times the height. So since you know that, using this, what is the area for a parallelogram?
Base times height.
And how do you know that?
Because a parallelogram is still a rectangle, just in a different form.
Mm-hmm. So you never took anything away? And what two things stayed, or what stayed the same?
The height.
Mm-hmm. And then the base is the same length, just switched around. So now we're going to move on to triangles. So we're going to begin with these two triangles. And what I'm going to ask you to do is there any way you can take these two triangles and form a parallelogram with them?
Uh-oh.
Awesome. So Taylor took these two triangles and she put them together like this to create a parallelogram. So, looking at this parallelogram in front of you, can you derive a formula for a triangle, since you now know the formula of a parallelogram?
Base times height divided by 2.
Mm-hmm. Perfect. So, now you're going to take, we'll use this triangle, and this triangle, and I want you to, or actually, let's use a little bit bigger one so it'll be easier to fold. So I want you, this one will just be for comparison, and so I want you to take this one and I want you to fold it so that you create a height line.
Oh.
That's okay. If you want to fold the other one, you can, and just use that one for comparison. Awesome. And then I want you to take the top vertex of where the height ends and pull it all the way down to the base and then fold it. Mm-hmm. Perfect. Go ahead and unfold it, and then I want you to cut off that triangle that you created at the top. And then I want you to cut the triangle in half on that crease line. Some big scissors. Okay, so then I want you to see if there's a way to use those two triangles to make that a rectangle.
Evenly? Or?
Close enough to a rectangle. Thank you. So So Taylor arranged these shapes. She put the rectangles at the corners to make a rectangle. Thank you. I mean the triangles at the corners to make it a rectangle. So, looking at this rectangle now and comparing it to the triangle, because I gave you two congruent triangles and then you cut one of them. So comparing these to each other, how do you know that the rectangle and the triangle have the same area?
Because I never took any of the pieces away.
Good. And then how do the bases of the triangle and the rectangle compare?
They're the same.
Correct. And how does the height of the rectangle compare to the height of the triangle?
It's half.
And then can you write a formula for the rectangle using the dimensions, the height and the base of the triangle?
Isn't it just base times height?
So our bases stayed the same, but what happened to our height?
Oh, base times height times 2. Divided by 2?
Divided by 2, there you go. All right, so then we're going to go on to another triangle activity using these two triangles. They're also congruent triangles. So what you're going to do is you're going to make that height fold again, or here, we'll go like this. Go ahead and make the height fold on that one. And then I'm going to have you take the outer corners and fold them into the height line. And then go ahead and unfold that. And then I'd like you to cut off those outer triangles that you created. Then using those, that's okay. Using those pieces, try and create a shape that you recognize using those pieces.
Any shape?
It might help if we make the cuts a little bit cleaner just so that you can see.
Of course it works for you.
So try and create a shape that you recognize. And it's going to be a little uneven because it's not always perfect. But yes, so Taylor, Taylor used the shapes that she had. She put them in the corners up here and created a square with both of those triangles. So now that you have a square and you have this triangle, how do you know that the rectangle, or the square, and the triangle have the same area?
Because it never took anything away.
Good. How do the height of the triangle and the rectangle compare?
They're the same.
And how does the base of the rectangle compare in length to the base of the triangle?
It's half.
So, can you write a formula for the rectangle's area relating it to the triangle? So using
Base
the height.
times height divided by 2.
Do you divide the entire thing by 2?
Height times base divided by 2.
There you go. Good job. So, we just created 3 formulas for triangles. Do you think all of them are equal to each other? Do you think they all give you the same values?
Like number-wise or?
Number-wise, yeah.
No.
No. Why do you think no?
Well, they weren't the same size triangles.
But if we just derived a formula from it. So if I use that formula and I use it all on the same triangles, like all
but
three of
doesn't
these-
matter what number?
No, yeah, it doesn't matter what
same.
number. Yeah, okay. So sorry if that was weird wording on my part. So yeah, so all the formulas will give you the same answer. Do you think that there would be a time when one form would be easier to use than another? Like think about if you were given one of these values.
Well, wait. Well, it depends on whether or not you're, like, with this one, the height was divided by 2. Or yeah. But for this one, it was the same. And then that one was multiplied by 2.
Yeah.
So it depends on what you're trying to figure out.
Yeah, awesome. Now we're going to move on to trapezoids. Fun, fun, fun. So, I'm going to give you a parallelogram and a rectangle. I want you to look at those and using one cut, make a trapezoid. One cut on both of them. How can you make a trapezoid?